If you go onto Blackboard, there's a section, a tab on the left-hand side where it says Exam 3 or Project, right? So you have an option. For the end of the semester, meaning next week is the end of the semester, believe it or not, for the end of the semester, you can choose either to take an online exam, Exam 3, very similar to the other two exams, probably a little bit briefer because there's not much material that we've covered since the Exam 2. That exam is non-cumulative. It will only cover the material we covered since the last exam, which would be correlation, regression, and I believe analysis of variance. I think we did, or maybe I did it the other way around. Was maybe it's chi-square and crosstabs.
Okay,
It was already on the exam, then it's analysis of variance, yeah. So it's only that material from them. Probably be a problem on each of them and a few short answers or something like that. Will not be that involved. Same rules. Open book exam, you can use a textbook, you can use anything on Blackboard, but don't communicate with each other. You have to do the test on your own. You'll have 2 chances to do the exam. I'll post it so that it's available probably on Monday morning, and it'll stay available until Thursday night. Okay, so you have 4 days in which they take the exam. But that Thursday night is a hard deadline. I can't stretch it any more than that because I've got to get grades in. I have to grade those things and get them in. Okay, if you prefer, you don't have to do an exam. Instead, you can do a project. And the project is a description of the project. The project is basically what you would see on a poster presentation. It's 5 to 7 pages, printed large, like 18-point text, so that you could read it from a couple of feet away, right? So we're not talking a lot of words, but in the project, I'll open up Blackboard maybe I should open up Blackboard and just go over it since it's come up, and it seems like maybe we're not all entirely clear about this. So just to make sure that we're clear about it.
Is there an example on the Blackboard? I think I remember.
I might have in one of the previous videos or one of the or on Blackboard somewhere, I might have put kind of a rough look at what it might look like. But I'm going to go over that now. Okay, let me see if I can't get on to Blackboard. Okay, and let's see, here we go. So I know some of you guys that are online now might be from other classes than Bio 610, but that's okay. It's basically the same kind of situation in the other classes as well, except for some of you nutrition students, you have to do the project instead of the exam. We want you to do some hands-on work, or for some of you guys that are in 611 where it's strictly a project also. Okay, so here we go. Here's a project exam 3 or a project option. So project. Okay, I actually have it due for Wednesday night because that's our class, basically been our class night. So here is a description of what the project should include. Okay, takes a moment for Microsoft Word to finish talking to itself so I can scroll. Okay, here we go. Okay, so basically what we're asking you to do is something that would look like a poster presentation. If those of you that are actually going to be presenting this in class where it's a brick and mortar course, you'll be printing it out onto paper and we'll be able to pin it up to some foam board so that you can display it as a presentation and take 3 to 5 minutes to communicate to us what you've done. So basically, what is that going to include? You're going to examine using one of the databases that we've provided, Community Health Survey. We happen to use the one from 2013. A simplified version, a scaled down version of it that has mostly data that involves insurance and ethnicity and flu vaccination information, frequency of flu vaccination information. Some other databases that are also available to us as well. But using these primary databases, you can choose any data that's in there, any variable that's in there. For instance, one of the simple ones happens to be, for instance, whether a person is insured, and whether or not they're likely to get a flu vaccination, right? Hopefully you get a little bit more adventurous, but that's the simplest version of it. So it's two variables, right? So you would look up those two variables on here and use SPSS to evaluate those two variables. In other words, insurance and influenza vaccination. You might say to yourself, well, is there an association between whether a person has insurance and whether or not they're likely to get vaccinated? On the other hand, you might also look at it from the perspective of where do they live? What borough? Maybe there's a difference between different boroughs, the rates of flu vaccination. Maybe there's several different. When we look into these things, you'll see this. There's the simplified version of the community health survey has about a dozen variables in it. Okay, just one of them, just two of them are flu vaccination and insurance status. So you might create a null hypothesis that there's no association between insurance, whether you have insurance and get a flu vaccination, an alternative hypothesis that there is an association. So in that kind of data, if it's categorical data, you're either insured or not insured. There's also, I think, a categorical data in the form of the type of insurance that you might have. So you might examine different types of insurance in terms of vaccination rates, Medicare, Medicaid, so on and so forth. My guess is, I'm going to take a wild guess and say that people that are Medicare are more likely to get a vaccination than people on private health insurance or employer health insurance. Why might that be? What do you have to be to get Medicare? You got to be old, right? So old people tend to get, they're worried about that stuff and they get their injections, right? All younger people say, yeah, I'm not going to get this, right? Exactly. So there might be a relationship there. It might be interesting to examine. Now, what are we going to ask you to do? First of all, we ask you to introduce this. In other words, tell us what you're examining, what you plan on showing us, and so on and so forth, what your objectives are, your research objectives are, what you want to prove with this evaluation. Then we might ask you to present your descriptive statistics. Tell us what percentage of people in this population are insured. What percentage of people get flu injections? What percentage are males and females? What's the age distribution of this population? I can tell you right away that if you draw a histogram of the population from which this sample has been taken, right? This is about 8,000 people. Population that this sample has been taken, you'll see there's nobody under 18 in this population because they don't sample anyone under 18 years old because of privacy concerns, right? So you'll see that. Is it an older population, a younger population? You'll be able to look at that just with a simple histogram, and we've learned how to do that in SPSS presumably. So give us some descriptive statistics relative to just an idea what this population is like, and also descriptive statistics in terms of the variables that you're going to examine. Okay, then tell us what kind of methods you plan on using here. In other words, how are you going to organize this data? How are you going to analyze this data? Are you going to use a chi-square? Are you going to use a t-test? Are you comparing averages? So on and so forth, odds ratios and so on, right? Tell us what you're going to do with that. And then present the results of your statistical analysis. So a big part of this is choosing the variables you want, then choosing the correct statistical test to analyze those variables. So for instance, if you wanted to know whether left-handed people or right-handed people were more likely to get a vaccination, you wouldn't use a t-test because that's categorical data, right? So yes or no, it's yes or no for left-handedness, yes or no for vaccination. It's not something you can take an average of. So t-test you use for averages. If you wanted to know the average age of people who were average age of males that were taking vaccinations or average age of females that got vaccinations, you could use a t-test because you're comparing two averages. The age is presented here as both in categorical form and also as a number. So you could use that test. In this case, the one I described, you probably use chi-square. If you're looking at, say, a borough of residents and whether or not they got flu shots, that would be 5 boroughs. And yes or no for whether or not they got a flu injection, that's a 5-by-2 table. You can only do odds ratio for a 2-by-2 table. So, you won't be able to do odds ratio, but you can certainly do chi-square to demonstrate that there is some association between what borough you're in and so on and so forth. And you can get the percentages by rows and things like that to get an idea of which boroughs are more likely to get flu vaccines, which ones are not. Then you could also, if you're really adventurous, you could focus on a particular borough and maybe compare two boroughs. Compare Brooklyn, compare the highest likelihood to the lowest likelihood borough. Maybe Brooklyn to Manhattan. And if it's a 2x2 table, you can then analyze with chi-square and odds ratio whether there's a relationship between being in one of those two boroughs and getting a flu vaccination, and even what the odds would be comparatively for those two boroughs. You could also, for instance, look at the odds of any particular borough versus the entire population, and that would be a 2x2 table. But you might have to do a little transforming of your data. I'm going to play around with that in a second. Okay, so we want to see what we want you to present your study. Now, normally on a poster, you would not present your null and alternative hypothesis. It would be nice if you did that for us because this is still a statistics course, right? Not 100% necessary, but probably a good idea. And then do your tests and put your tables and whatever your results are there. And then finally, a discussion and conclusion. In other words, what do these results mean? Did you find, were they statistically significant? Were they clinically or practically significant as well? In other words, you can get a result that says, if you're in Brooklyn, if you live in Brooklyn, you're 0.1% more likely to get a vaccination than people in Queens, right? And that might be, because it's such a big sample size, 8,000 people, that might be statistically significant. Your significance might be less than 0.05. But is it practically significant? No, it's only a little teeny tiny difference, right? So you might want to discuss that, what the conclusions are from your analysis. Okay, so now one other thing is in the introduction section, when you are giving us some information about what you plan on doing or what your objective is, you should do a quick literature search. Find a couple of articles that addresses what you're talking about. I'll bet you can find Medline or somewhere else, one of the many databases that you're access to through Hunter and through School of Public Health, that you can find articles about Medicaid and influenza rates and influenza vaccination rates and so on, or just in general, compliance with vaccinations and so on and so forth. So do a little bit of a literature search to get, so I get an idea that you're comfortable with not just figuring this stuff out in your head, but also standing on the shoulders of giants, going back and see what other people. So what's the objective here? The objective here is, instead of doing another third test, and in which you're going to remember what we did here for, let's see, we in the last 2 or 3 weeks we did, say, analysis of variance, chi-square, correlation, regression. Now you're going to study it for the test. You're going to take the test, and then 5 hours later you're going to forget it, right? That's not our objective here. Our objective here is that you learn these tests. You learn how to use statistical analyses and tests and the tools, SPSS, Excel, and so on. You learn how to use them and employ them, because when you take epidemiology, when you take other courses, you may be called on to do this kind of stuff as well. Do a statistical test to collect data, then decide how to handle it. And to be honest with you, it's good to know what statistical tests you're going to be applying before you collect the data, right? Because otherwise you're painting yourself in the corner. You may not be gathering the information you really need to demonstrate what you want to demonstrate. So you even think about this even before you actually do a study, of course. So the idea is that you take this, what we've talked about, and put it into practice. Now it's up to you. It's up to you guys. A couple of departments, nutrition says, gee, we really want these students, brick and mortar, showing up to class, getting hands-on and stuff like that. So I would prefer that, nutrition students should really be doing a project. If there's some reason you can't do the project, you can communicate with me, and you can do you can do the online exam instead, if you're more comfortable with that, or you have a reason why you can't do the project. But for the rest of you, you're going to have a choice, right? Except for 611, you're also doing a project. The rest of you guys, in Bio 610, you guys have a choice. You choose to take the exam, right? Or you can choose to do the project. Unlike those other classes, which are brick and mortar, you're not going to come in here and print it out and put it up on a phone board and then stand in front of it for 5 minutes and tell us about it, right? You're just going to upload it to Blackboard, right? So a lot of people use PowerPoint, for this because it's easy to put in charts and move text around and so on and so forth. So what does a poster look like?
We're not, it's not mandatory for us to come to class and present it.
Not if you're in 600, right? Because it's an online course. Not if you're in 610.
Right.
610 is strictly online course.
Right.
If you want, I'll come in, I'll drive in if you want to stand here alone with me and present it. But unfortunately, I would love to do it on. Yeah. Oh, okay. Which class are you in?
I'm on Monday.
Oh, okay, 611. Okay, yeah, you have to show up. Okay. Okay, so yeah, I think I went over a little of this in 611.
Yeah.
Okay, so this is a typical poster session. People doing research summarize that research very much like this: introduction, objectives. They put together some graphs and tables describing with the descriptive statistics. They do statistical tests, analyses. They present the data they've collected along with analyses if they're appropriate. Then they talk about their conclusions, further research they're going to be doing on it, questions that arise from this. And you would at a conference would walk up and down these rows of posters. And if you see a topic you're interested in, you might stop and talk to the author of that research, who would be standing right there. Okay, so let me see if I can't show you a quick look at one that's more a little bit close up of one. Here you go. Here you go. Let's take a look at this one. Now these are professionally printed, right? Obviously. You're not going to do that. You're just going to print out your introduction and so on and so forth, and maybe your descriptive statistics like this, graphs, very much like this. Looks very much like what we're after. And then you might talk about in fact, look at that. They're talking introduction, some descriptive statistics, methods, conclusions, and future work. And so that's almost exactly what we're looking for here. Does that make sense to you guys? Right? And then in here, they put their results in. So they didn't follow the same order I put it in, but it looks great, doesn't it? I mean, it actually makes even more sense, right? So this is kind of the amount of text you might have. The more concise you are, the better. But you want to still communicate what you're doing and what information you need to, and what tests they I can't tell if they did. I can see percentages here. I don't know if they did a statistical test here. You can probably get a better look at that. Okay. In fact, you know what I'm going to do? I'm going to pull this. This is so much like what I would like you guys to do. I'm going to put it up on Blackboard later as an example. Okay, our version of it, we're going to print it out on 8.5 by 11 pieces of paper, and you're going to take push pins and we're going to assemble it into something like this. Okay, and then you stand there for 3 to 5 minutes and present what you've analyzed, what you've done, and so on and so forth. We may answer questions and so on. Okay, so that's what we're after. The exam, very much like the exam 1 and 2, except limited to the last couple of topics that we've covered. Probably a problem in each area, like correlation or regression. And I don't remember the exact order for each class. It might be a little bit different, but it was either analysis of variance or chi-squared, depending on what it was that we've covered in your particular class since the last time. Okay, so I got a couple of questions here. Okay, just to be certain, there were no practice tests. There were no practice tests for NOVA correlation regression. I did not see any. Nope. Odds ratio is a 2x2 table. However, it does not matter if it is categorical for numerical variable. No, odds ratio is strictly for categorical variables, right? So numerical variable would be like age, right? If you have something like that, you're going to take an average. You're going to compare averages, right? If it's a numerical variable, age, blood pressure, you'd be comparing the average blood pressure, average age, average blood pressure for two populations, if it's analysis of variance for more than two populations. So that's one variable is categorical, like gender or ethnicity, and the other variable is numerical, like blood pressure or age or something like that. You would, but odds ratio is strictly for 2x2 tables where they're both categorical, they're both dichotomous, meaning they have two values. So for instance, it might be gender, male or female, versus whether or not they had a flu vaccine or didn't have a flu vaccine, right? So each box, if you put the gender in the rows, male, say a female on top, male on the bottom, and you went across, and the first column was got a flu vaccine, second column was didn't get a flu vaccine, well then the first box on the upper left hand would be females that got a flu vaccine. The next one would be females that didn't get a flu vaccine. Bottom row would be males that got a flu vaccine, males that didn't get a flu vaccine. And then from that, you could do chi-square, or you could do relative risk, right? You could do the percentages by rows, percentages of males and females got flu shots, and you could do odds ratio and in addition relative risk, right? So if you need to, you can go back over that. Yes.
The odds ratio is only 2x2, right?
Yeah, you can only do it. In fact, when you try, if you had a table that was like ethnicity and had 5 values, or boroughs, let's say 5 boroughs,
Right.
and you had flu vaccine, yes or no, and you had 300 people here and 800 people here and 1,000 here, and so on. If you did chi-square, no problem, it would let you do that. But if you tried to do odds ratio or relative risk, if you checked off risk in the statistics box, then it would give you a warning says you can only do that for a 2x2 table, right? Because think about it. It's you have to calculate the odds for the top row and divide it by the odds for the bottom row, right? A over B divided by C over D if you're looking at it with letters and stuff like that. Okay, so does that, Claudia, does that answer your question? And Sumo, okay, good. And on the exam, just like the previous versions of the exam, okay, well, for the online course, for Bio 610, okay, I'm gonna make it available on Monday morning, and you'll have until Thursday night to complete it. Now, the thing is, I'm going to give you 2 shots at it, okay, and it's going to work the same way. In other words, you'll be able to see which problems you got wrong, and then you can go back and get one more attempt at it. It'll be timed, so once you start, you gotta sit there and finish it, but you'll have 2 attempts at it. So in a sense, you'll have a preview. That's the exam itself is a preview of the exam. Okay, so when you see the problems, one of the things I got to tell you, there's 60 people in this class. At least 5 or 10 people did not do their first attempt until 3 hours before the exam was due. Right? So what does that mean? It means you only get 1 attempt. Right? It's kind of silly, right? I mean, you really, you got, the first attempt, and unlike the first exam where unlike the last exam where I averaged at 2 grades, so you did get penalized a little bit if you didn't do well on the first exam. On this one, since it's very, very new material, it's a little bit more complicated material, a very new material. I will only count the higher of the 2 grades. Okay, so that first exam is a good preview for what you need to know. So you can go back, look through some videos, some PowerPoints, and get a better feel for what you need to do. Now, just keep in mind that when you go to take it a second time, you're gonna have to start from scratch. Not gonna fill in your right answers for you. You're gonna have to start all over again from scratch. Okay? Can I do please PowerPoint instead of poster project? The poster project basically is a PowerPoint. It's
The slide.
yeah. It's if you look at the picture I just showed you, let me open that picture again. If you look at that picture, you can almost look at like this is a PowerPoint slide. 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 So it's really the poster is really basically a PowerPoint slide. Now, a lot of people use Microsoft Word to do this. I don't like that personally because you know how it is Microsoft Word. You put a chart or a picture into Microsoft Word. It's hard to manipulate. It's not really a layout program, right? You got to, does this go behind the text, in front of the text, in line, out of line, and so on and so forth. So it's a little bit harder to come up with, like neat arrangement of tables and things like that. But I mean, really, I think if I were going to do this myself, right, I would use PowerPoint because it's so easy to lay this out. And it doesn't have to look fancy like this. Doesn't really need this big thing up here on the top. It doesn't need a picture of people standing around in a conference table and stuff like that, unless it's relevant. It might be something. Maybe it is you could show a line of people waiting for a flu vaccine or something like that, or a picture of like somebody somewhere where you can get free flu vaccines or something. Maybe, it's up to you. But in this area here, again, tell us what this is about. Tell us a little bit of background on the topic, maybe, and give us a reference, at least one reference, maybe two, that you looked up. Wikipedia doesn't count, right? We're not talking internet references. We're talking like real papers, that you might dig up that have something that vaguely to do with the topic that you're looking for, and give us, your statistics, your descriptive statistics, the analysis that you did, the methods that you used, the results of your descriptive statistics and analysis, and then give us your conclusions. And in this case, they talk about future work. You can tell us, I don't think you have to go quite as far as suggesting future work, but if it's relevant, that sounds great to me, right? Just discussions and conclusions would be good, but if it's something that suggests that maybe somebody's interested in doing some more research on this topic, then by all means, put that in as well. Okay. I mean to present in class on the computer or on the pad. I don't think it's going to be practical for us. For those of you that have to do it in person, it's not going to be practical for us to do a PowerPoint on the board. Because what we do is we set up easels, like 6 or 7 easels, and everybody goes up there. First group goes up there and posts their stuff, and then we go person to person to person. And as we're getting them done, the first person pulls their stuff down, somebody else behind them put stuff up. So we go through that. It's not going to work. Really don't think it'll work out on a practical basis for us to do it on a screen. Okay, so can I answer any other questions before I go on and just talk about and give you an example of what an analysis might look like? Okay, so I'm going to go ahead and do that. Okay, so among other things, we have these main sets of data here that we're working with. Okay, and I'm sure I have it downloaded here somewhere, but I'm going to put it on my desktop now rather than spend time looking for it. Okay, here is a simplified data set. I'm going to drop that on my desktop. And here is the code book for that data set. Codebook has the information that tells us what questions were asked and how the data was coded. In other words, the data was entered as a number. So for instance, you ask somebody, did you have a flu shot or did you not have a flu shot? Well, 1 might represent they got a flu shot, 2 might represent they didn't, or vice versa. So you need to know that if you want this to work. Okay, so this is the simplified flu coded. Okay, this is a coded version of it that we've already coded for you. Let me pull down the full data set. Okay, so I'm going to go to them and open them up in SPSS. This is the coded version of the simplified flu set. Okay, I think it's opening. Yeah, there we go. Okay, So it opened up, as it happened, it opened up in the variable view, right? SPSS, remember we have the data view and we have the variable view. So it opened up in the data view. In the data view, we can see each line represents a variable. In fact, since there's 10 lines, you know there must be 10 columns of data. Each one of these represents a subject. This person, 57 years old, lives in Brooklyn, is white, let's see what this stands for, is less than 20% below the poverty level, doesn't have any data about whether they're insured or not. So tell you the truth, I think SPS, if you use this variable, SPSS won't count this one. This person's insured, they're on Medicare, they got a flu vaccination, they're male, they're US born, that's called nativity, and they don't have any children under 13, I think. Whatever, that's what I think that means. We'll see in a second. Go to variable view, and this is coded, so you can actually see what each of these, you have the variable name, you also have the variable label that describes what information that is. Number of children under 18 years old living in household is what that was. Okay, so for instance, borough of residence. Okay, if I click, that's the variable borough. If I click into that on the values, it'll tell you that 1 represents Bronx, 2 represents Brooklyn, 3 represents Manhattan, and so on. So if I wanted to summarize the number of people that got flu vaccines for each of these different boroughs, I could go up here to Analyze, Descriptive Statistics, and I could go to crosstabs. Remember, this is categorical data. And I could say, let's see, borough of residence is in rows, and whether or not they got, well, actually, maybe I'll just, whether or not they got a flu shot, I'll put in here. Okay, so what can I do here? Well, I'm not going to do any statistics right now, but you could click here to get chi-square, click here to get risk if it's a 2x2 table, which I think it probably is. In cells, I could ask it to give me observed values, ask it to give me percentages by rows, for instance. I'm going to click continue, and let's see if there's anything else. Okay, I'm going to just stop with that. Okay, and our output window is going to open up, and here's our table. Bronx, this is the number of people that lived in the Bronx that were surveyed. This is the number of people that got a flu vaccine. That's 46% of them. 37% of people in Brooklyn got a flu vaccine. 52% of people in Manhattan got a flu vaccine. That's interesting, right? Think about it. Why would it be so low in Brooklyn as opposed to Manhattan, the Bronx? Maybe you want to take a look at, the percentage of people that have insurance in those different neighborhoods, something that might influence that. So you got somewhere else you can look. So what kind of analysis could we do on there? Could we do odds ratio here? No, we can't because it's not right. So, but we can do a chi-square. We can say, is there an association between, there's no association between the borough you live in and the whether or not you're likely to get a flu shot, meaning that all the percentages are the same, or the alternative is that there is an association between the borough and so on. And it looks to me like you're going to get, you're going to reject an null hypothesis there. Right? On the other hand, you could say to yourself, gee, I want to look at, say, which is the one that's highest. Highest is Manhattan. Lowest is Brooklyn. So let's say I want to compare Brooklyn and Manhattan directly. What's the, I'm sorry?
The big population is against vaccination.
Oh, no kidding. What, but because of why? Because of religious or, yeah.
A lot of new era people.
Yeah. A new era people. You're saying, but nobody in Park Slope is getting a vaccination. Is that it?
Yeah.
That's what it sounds like. You're yeah, maybe. Oh, here we go. Okay. Well, maybe a younger. Maybe you could examine that too. Yeah. Does Brooklyn have a younger population? Do they have more people that are not native to New York? Right? Do they have? You can look at a few things, right? I don't want to make you crazy on this. Remember, suppose this is 7 pages. This is not a thesis. This is I'm more interested in demonstrating to me that you know the basics, that you understand what kind of data you're working with, that the data that you're working with, if it's categorical, if it's numerical, if it's so on and so forth, the type of data determines what test you use. If I were to ask you, what's the average age of people in Brooklyn versus the average age of people in Manhattan, which I think I just brought up, you would use a t-test, right? Because you're comparing two averages. If I asked you what's the average age of people in all the boroughs, and if they're the same or different, well, that's now 5 averages you need to compare. You would use analysis of variance because you only use t-tests for comparing 2 averages. Analysis of variance, you use to compare 3 or more at the same time.
For this kind of result that you want to, for the hypothesis you want to do,
Yeah.
this data is not the best one that
Yeah.
you do.
Okay. So let's
No,
say,
it's only a comment.
yeah, let's say I wanted to compare just Brooklyn and Manhattan. I don't have a variable for that, right? Well, how about I do this? How about if I say to myself, let's say, okay, instead of borough of residence, I'm going to make a new variable. Transform, I'm going to say recode into a different variable. I'm going to take borough of residence, right? And I know that 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 Brooklyn is 2 and Manhattan is 3, right? I'm going to go in here and I'm going to say borough of residence. I'm going to say instead of borough Manhattan versus Brooklyn, right? I'm going to give it a new variable name, and I'm going to say in this new variable that what did I say? 2 and 3? Did I say 2 and 3? I forgot already. That didn't take long. I think it was 2 and 3, right?
Yeah.
Okay, that the value 2, which is Brooklyn, is now 1. Okay, and the value 3, which is Manhattan, is now 2. And then that's all I'm going to do. I'm not going to copy over any of the other data. And I'm going to say, okay, I'm going to label it Brooklyn versus Manhattan, right? Because that's not the variable name. Variable name can't have spaces. I'm going to say change. I'm going to say okay. So now a new variable has been created. Here it is down here, borough Manhattan, Brooklyn versus Manhattan. And what did I say? I said, now I have to go back and recode this. 1 is Brooklyn. 2 is Manhattan. So I have a whole new variable here, right? So let me go back here just to make sure that I got it right. Oops, nope, that's nativity. Where's borough? Here it is. Did I get it right? Yeah, I got it right. As it happens, I got lucky. What's that? 2 and 3. That's what I said, right? Well, it doesn't matter what I put. In other words, I created a new variable. I can make it anything I want. Okay. So now when I go to analyze and I go to descriptive statistics and crosstabs, I'm using crosstabs because they're 2 categorical variables. Crosstabs, and they say now not borough of residence. I'm going to say Brooklyn versus Manhattan in the rows. So only going to be 2 boroughs in the rows now, Manhattan and Brooklyn. And I'm still going to look at it and see the percentage of people that got flu shots. I click OK. So now I got a new table, which is only a 2 by 2 table. And it shows me 37% Brooklyn, 52%, so on and so forth. Now I can run a chi-square. I can run an odds ratio, analyze descriptive statistics, crosstabs. I can run, let's say, I'm going to go into cells. I can do, I already got percentages by rows. We go into statistics. Let's say I just do risk. I'm not going to bother with chi-square right now, just do risk. Okay, let's see what I get. Okay, well, the odds ratio for Brooklyn versus Manhattan is 0.59, 0.55. The odds are 55% for Brooklyn, 55% of the rate odds for Manhattan that you would get a flu shot if you're in Brooklyn. Is that significant? Is that a significant result? Well, the 95% confidence interval is for the odds ratio is not here. Doesn't have 1 in between them, right? So you can reject the null hypothesis that the odds ratio is equal to 1. In other words, that the rates are the same. Notice it came out to be a number less than 1, right? So if we wanted to show this a little bit more clearly, I might have instead told it that make Brooklyn, make number 2 in the original database, number 2 in the new database, and make Manhattan, which was number 3, number 1. And what would that do? that would put Manhattan on top and Brooklyn on the bottom, and the odds ratio would be a number bigger than 1. So you could say that, and the relative risk here is 0.17, 0.71, right? You could say that, oh, the likelihood of you getting a vaccine if you live in Brooklyn versus Manhattan is you're 30% more likely, 1.3 times as likely, right? So you can manipulate these things so you can get the data to do the best job of explaining the differences and so on. Okay, let me just take a quick look online here. Okay, guys. Okay, good. Okay, so you have this data. It's already coded for you already. Between me and you, not very challenging, right? Because it's all coded, it's laid out for you, and so on and so forth. Well, let's take a look at the main database where this came from.
You told me like last week about how you can highlight just the ones that you want to keep and then.
Yeah, sure. I mean, to be honest with you, there's a million ways to do this. If you want to work with the database in a way that doesn't delete information, you don't lose information, you can use filtering. But to tell you the truth, for our purposes, it's easier just to delete the rows. It's just like doing it in Excel. In other words, you want to get a row, you just highlight it.
No, I create a new one.
Yeah.
And I keep, and I copy.
Oh, okay.
Yeah, you could you could copy. Yeah, you could copy and paste if you wanted to. I'm not sure what happened here. Okay, open. I don't know why you did that. Maybe I didn't download. You don't have to do anything exotic unless you're dealing with small data sets. You know, like uh, uh, McNamara or any of the something like that, or I'll open it and see if I can get this open. Okay, I'll work that time. Okay, so now here's the full data set. 2 issues with this is, one is that this data set has 200 variables in it, right? Actually 209 variables in it, right? So how do you know what this stuff means? Well, you have the variable name here, and you also have under the label, you have the question that was asked. And a lot of these, based on your zip code, you lived in there, it's a lot of words in there, right? So what you may want to do is that there's information here on colonoscopies, on, we're not saying you have to talk, you have to be interested in flu vaccines, right? You have information on diet, on sugary drinks, on smoking, on mood disorders. How often have you been depressed in the past year? Are you taking medication for a psychiatric? And there's all sorts of information in here. Okay, and the label has the question. Now, the only problem is that label is going to wind up on your table or your graph. So you may want to alter that, type that, you change that label so it's summarized a little bit, so the graph is more readable. The other problem that you have here is, for instance, if we're looking at, have you ever been told that you have diabetes? Right there, we're looking at that, right? Well, let's see. What is that? That's the 32nd column across, diabetes 13. And let's see if I can't find that real quick. Tell me if I go past it. There it is right here. What are the numbers you see in there? They're 1s and 2s. That's because if I go up here to view and turn off value labels, turn on value labels, it just stays the 1 and the 2 because it's not coded. So I have to go back here and I have to tell it that for diabetes, that the values, 1 means yes, I think, and 2 means no. Okay. Now, how do I know if it's yes or no? I know that from the code book. And you can download the code book. I did it in the background, I think, while we were talking. Here's the code book. Right? The code book tells us, where'd it go? There it is. Okay. The code book tells us, it's a PDF file. The code book tells us what all these questions. First of all, number 1, it tells us some information about the study and so on and so forth, but it tells us all of these different variables, what the question was, what the variable name is, and what all the different values that were entered for it. So for instance, mood one, during the past 30 days, how often did you feel so sad or depressed that nothing could cheer you up? All of the time, this is a categorical variable, right? All the time, most of the time, some of the time, a little at a time, none of the time. It happens to be ordinal, but it's still a categorical variable, right? So on and so forth. What about the one we were just interested in, diabetes 13? I'm going to do a search on that. Diabetes 13. Okay. Okay, did I find it? Yeah. Diabetes 13. There it is. There's diabetic 13. You're right. You're right on the page. Okay, have you been told? Yeah, and one happens to be yes, and two happens to be no. So I was right. We coded it correctly. So now when I use it, when it creates a table, it will say, yes, sir, are you diabetic? Well, you might want to change this to, have you been told you're diabetic, right? Or just diabetic, period, right? And then one and two would appear as yes or no instead of one and two. So then people would be able to see that chart and understand what that chart represented, right? If you don't do that, the chart will just have one and two. So for instance, for here, for instance, let me find something else here. Smoker is 42. I don't know what the status is there. I'm going to go to analyze. I'm going to go into descriptive statistics crosstabs. I'm going to say, in the rows, I'm going to say smoker. Okay, smoker status. Okay, I'm going to put that into the rows, and into the columns, I'm going to put our diabetes, the one we just identified. Have you ever been told that you have diabetes? You put that into columns. I'm going to go into cells. I'm going to show me the observed values. Going to show me the percentage by rows. And click OK. Let's see what we get. Okay, and it tells me that, gee, among smokers, right? Well, hang on a second. It just put one and two for smokers, right? Not whether a person was a smoker or not. So if I didn't know better, I wouldn't know which line here represented smokers and which represented non-smokers. Actually, I think one is smokers, two is former smokers, and three is don't smoke at all. But in the columns where I coded it, instead of putting one and two, I put yes and no. So I know what that means, right? So I could do a chi-square here. See if there's a relationship between smoking status and whether or not a person has been diagnosed with diabetes. Right? So I can't do an odds ratio, right? Because there's three values in the rows, and so it's a 3x2 table, not a 2x2 table. Now I could say to myself, I don't need this middle one, which is smoking, former smoker. Maybe I'll just compare current smokers. Actually, what I could do is I could combine current smokers and former smokers into one variable. Let's do that. I'm going to go up here and say transform, recode into different variables. And I'm going to say, let's see if I can't find it. That was smoking status, right? I've been told by diabetic. Come on, smoking status. Here we go. Okay, I'm gonna move that in there. I'm gonna make a new variable, smoker. Smoker, yes or no. Smokers versus no, none. And I'm gonna put down here smoker or former versus non-smokers. Okay, and I'm going to say the old values. Okay, one was a smoker. I know, I vaguely remember this. Okay, one was a smoker, so I'm going to say, okay, the new variable is going to have one. Okay, two represented former smokers. I'm going to combine them with the smoker. So if it was a 2x4, two before, It's going to be a 1 now. Okay, and then finally 3 non-smokers, I'm going to make that a 2. So in our new variable, right? In our new variable, the smokers and non-smokers, I think I blew it here. That should have been a 1. In our new variable, what did I just do here? 2 becomes a 1. I already have it there. And 3 becomes a 2. Yeah, there you go. Okay, yeah. Yeah, because when I redid it, it screwed things up. So what's going to happen here? People who were smokers are now going to be classified as 1. People who are former smokers are going to be classified as 1. And people who are non-smokers, never smoked, are going to be classified as 2. Okay, so any kind of smoker, former or current, is going to be a 1. And anybody who doesn't smoke is going to be the other value. And I'm going to say, go ahead and change it. Say, okay, now I have a new variable. Right? And this new variable is going to be way at the end of the list. Well, gee, now it's way at the end of the list down here now, right? But that's the one I want to work with. So maybe what I'll do is I'll take all the rest of these, right up to diabetic, which I think is about 32, right up to diabetes. I'm going to highlight all those. I'm going to say edit. I just held down the shift key. Edit, and I'm going to say the clear. Bingo, they're gone. So now I'm going to get rid of these 2. Let's get rid of all these. Okay, so now I could say save as, and save it as a new database so that my original database is still intact. You know, I haven't erased that, it's still there. I'm going to say 2 or something like that, put it on the desktop. But now I only have the 2 variables that I need. I don't have all the other variables and stuff. So now I can go in here and say analyze, descriptive statistics crosstabs, and I can say, okay, ever been told you that diabetic, and now in the rows I can put smoking status, smoker or non-smoker, just 2 by 2. And say, okay, and now I have a 2 by 2 table, so I can do odds ratios now. Not only that, I didn't code it. It still says 1 or 2. Right, so I still have to go back there and code it. Let me go in here and code it. 1 represents current or former smoker, and 2 represents never smoked. Okay, so now I can go back to my analysis, and I can get cells, okay, and I can go into statistics and say chi-square and risk, and I can say, okay, let's see what we got. And there you go. Okay, here's my chi-square table. Here's my odds ratio and my relative risk. So, interestingly enough, take a look at this information. If you're a current or former smoker, there's a lower probability that you have diabetes than if you've never smoked. What do you think that might be? Why do you think that might be? If you have type 1 diabetes, you're not going to smoke. Probably any doctor in the world says you don't even think of smoking, drinking, eating sugary stuff, right? Maybe people who have been diagnosed with diabetes don't smoke. I think. Maybe I screwed up the numbers here somehow. But that's also a possibility. When you spend more time, yeah, because of their diabetes, or they have potential to have diabetes. When they were diagnosed. Yeah, when they were diagnosed. Okay, so I think that's kind of the basics. I'm going to do another session on Sunday night, say 9 p.m.